In this lesson, we're going to illustrate the famous invisible hand theorem. The theorem was originally due to Adam Smith, but has since been clarified in very important ways. It states that when firms and consumers pursuing their own interests interact in markets, the outcome is somehow amazingly efficient. We're going to illustrate this idea with a simple example, the market for roses. There's going to be a consumer for roses, Tilke and Thomas. They like roses, but they don't have exactly the same preferences. There's also going to be two producers, Narivia and Nick. They don't have the same marginal costs either. But we're going to see how this whole thing works. Now clearly there's already some interaction. They're all here together in the rose market. Of course, a real rose market will have many more than just two producers and many more than just two consumers. So we're going to imagine there's a lot of other rose producers and consumers. But the question is, how do they interact and how do things change over time? So suppose, for example, that Thomas wants to consume more roses. He wants to consume more roses. If he's going to consume more, then Tilke is going to have to consume less, or somehow Narivia and Nick will have to produce more. How do we make this happen? Well, we'll have to think about that, but somehow it's got to give. There's an interaction of some kind. Or you could have Nick maybe his rose farm gets wiped out by a flood. So that's what's going to happen then. There's going to have to be fewer roses consumed for a while. Or maybe Narivia is just going to have to go wild producing tons and tons of more roses. How's that going to happen? We don't know. But there's got to be interaction. So how can we make this happen? Well, one idea, maybe a crazy idea when you think about it, but let's work it through, is that there's somebody coordinating this whole thing. Maybe me. And so I get the news that, for example, there's a wipeout of Nick's farm. Can't do much about that, but we've got to figure out what to do. So I'm going to just go over and tell Narivia, you better produce more. Will you produce more?
No.
You won't?
I want to produce more.
Oh, geez. Well, maybe Tilke can consume fewer roses. What about that, Tilke? Can you consume?
No, I don't want to consume.
You won't?
That.
Okay. Hey, Thomas, how about you? Would you consume fewer roses?
I can't do that.
So, I can coordinate in the sense send the information about the poor tragedy that's happened with Nick, but doesn't mean someone is going to respond. So you get this ability to communicate. Maybe even I have a sense of who should reduce their rose consumption more, Thomas or Tilke. But the problem is I can't really get them, I can't motivate them. I can say, please, Narivia, would you produce some more? No.
No.
I beg you, Tilke. Stop a little bit. Thomas, how about it?
No.
So you can see this is getting ridiculous. And you can see how it even would be more ridiculous if there weren't just four people in this market, two producers and two consumers, but there's hundreds and thousands as there are in the real world. In fact, many more than that when you consider other kinds of markets. Well, fortunately, we don't have to do this. In fact, that's the whole point of this discussion. We have markets to do this. And so I'm going to disappear, if you like, and my hands, if you like, are going to become invisible hands. And we'll see exactly how this works using our idea of the model, the supply and demand model. The supply and demand model, of course, has demand curves.
So this is my demand curve, and it's derived from my marginal benefit. The more roses I consume, the less marginal benefit I will get on each rose.
This is my demand curve derived from my marginal benefit. Together, our marginal benefits make up the market demand curve.
This is my supply curve, which is derived from my marginal costs. And you can see that as I produce an additional rose, my marginal cost goes up. It's different from the marginal cost curve of Nick.
And this is my marginal cost curve. As you can see, as I produce more roses, my marginal cost increases also. My curve and Narivia's curve together make up the market supply curve for roses.
So as you can see in the market diagram, the supply and demand curves intersect, and they intersect at a point which gives you the price. It's 90 cents. And you also can see they give you the total quantity transacted in the market. That's going to be 8 roses produced and consumed. Moreover, when you think about this model, you're getting more information just than the total that's produced or consumed. You're getting information about who's going to produce it, who's going to consume it. And in fact, what happens?
At 90 cents, I would like to consume 4 roses.
At 90 cents, I would also like to consume 4 roses.
At 90 cents, I would like to produce 5 roses.
At 90 cents, I will produce 3 roses.
So the market works. It adds up, it gives a price, it gives a prediction. And not only does it communicate information through the prices, it's coordinated. It's had Narivia producing a certain number of roses and Nick another certain number of roses. And moreover, it's motivated to do that because each one of them is considering about their own interests. Narivia is maximizing her profits. Nick is maximizing his profits. Tilke is maximizing her utility. Thomas is maximizing his utility. So they're all doing what they think is best on their own interest, and the markets are able to coordinate it in this way. Now the real question is, how good is the market at doing this? It works, it gets an answer, but is it a good answer? Is it efficient? Is it an efficient outcome? And to answer that question, we want to think about what it means to be efficient in a market like this. And there's 3 things to consider. One is to make sure that the total amount of roses produced covers the cost. So we want the marginal benefit to equal the marginal cost of that last rose produced. That's an important condition for efficiency. But in addition, we want to make sure the marginal benefits for each consumer are the same. And in fact, that if they weren't, there'd be a problem because if the marginal benefits for roses were much higher for Tilke than for Thomas, then they could trade. Thomas could give some roses to Tilke and he wouldn't be much worse off, she'd be much better off. So they basically have an agreement to do that, to make it more efficient. Similar with the costs. If the marginal costs of each producer are not equal, he can improve things. So another condition is the marginal costs for each producer are the same. So you have 3 conditions. To say it again, marginal cost must equal marginal benefit in the market. Marginal benefits for all the consumers must be the same, and the marginal cost for all the producers will be the same. Now the real question is, does the market deliver that outcome? And if you take a look, we'll be able to see whether it does or not. You see the intersection of the supply and demand curve gives a price of 90 cents, and you look over at the individual demand curves of Tilke and Thomas, and you see that Tilke has adjusted her consumption so that her margin benefit equals the price. That's the intersection of her margin benefit and the price line. Same with Thomas. Thomas has adjusted his consumption so that the margin benefit equals the price. If they're both equal to the same price, only one price there, 90 cents, then their marginal benefits are equal. So the marginal benefit for Tilke and the marginal benefit for Thomas are the same. So that condition for efficiency holds. Think about the producers now. You can see in the diagram they've adjusted their marginal cost equal to the price. Nick has his marginal cost equal to the price. Narivia has her marginal cost equal to the price. They have different marginal cost curves, remember, but they're facing the same price. So at that price, their marginal costs must be equal because they're equal to the same price. So the condition for the producers holds too. Marginal cost is equal for all the producers. Only 2 in this market, but of course the same would be true if there's more. And then finally, look at that supply and demand curve again. And remember the demand curve measures marginal benefit, and the supply curve measures marginal cost, and they're equal. So all 3 conditions for efficiency are hold. Not only does this demonstrate how the market works as we've modeled it, it demonstrates the market delivers an efficient outcome as we've defined it. So now that we've seen how the market equilibrium is reached and the production and consumption is coordinated, let's go back and think what happens in the case where Nick's farm gets wiped out. So now there's going to be a reduction in supply. The supply curve in the market is going to shift to reflect that less reduction. You can see it shifting. So now you're still going to have Tilke and Thomas maximizing their utility, and Narivia is going to be maximizing her profits. They're just facing different prices. So what happens to them? What happens, Tilke?
I'm just going to consume less.
At the higher price, I'm also going to consume less.
At the higher price, I'm now willing to produce more.
So the market has found a way to coordinate the fact there's less in the market. The price has risen, given a signal to Thomas and to Tilke to consume less, and it's given a signal to Narivia to produce more. Things have been coordinated because the marginal benefits of Tilke and Thomas are still equal at this new price. It's still efficient. And it's motivated people. Rivia has been motivated to produce more at that higher price, which is what you want to have for this efficient outcome. And Thomas and Tilke have been motivated to consume less at that higher price as they are maximizing their utility. So the market works beautifully to deal with this terrible tragedy of Nick's rose farm getting wiped out.